morning, students. Myself is Russell, working as assistant professor, the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. Today we are going to discuss about the Unit 2. Last session we have discussed 4 parts of Unit 1. We successfully completed that, and today we are going to see about the Unit 2, that is gear and gear drives we are going to see. So that will be very interesting topics. We will see one by one. So Unit 2 represents gear and gear trains. It covers spur gear, that is introduction part, law of toothed gear, involute gearing, gear tooth action, interference and undercutting, parallel axis, and epicyclic gear trains. We will see one few parts in this session. That is the introduction part of gear, that is used to transmit motion from one shaft to another shaft or between shaft and the slide. This is accomplished by successfully engaging the gear teeth. As already all are aware of that, it is a transmission of motion from one shaft to another shaft. That for that purpose only we are using gears. So what is the advantages means it transmits exhaust velocity ratio. It may be used to transmit large power. It has high efficiency. It has reliable service. It has compact layout. Disadvantages of the gear drives are manufacture of gears require special tools and equipment. Error in cutting teeth may cause vibrations and noise during operation. So these are the major limitations of this. So the manufacturing required very special tools for this. So cutting teeth may cause vibrations and noise. So applications, all are aware of that. What are the basic application means? Wristwatch, toys, home appliances. So in medium applications means we can tell as lathe, milling or machine, shaping machine, automotive gearbox, simple power transmission system, etc. For the large application we can utilize for turbine, marine, aerospace, cranes, etc. So classification of toothed gears. According to the position of axis of the shaft, we can classify as parallel, intersecting, non-intersecting, and non-parallel. According to the peripheral velocity of the gears, we can classify as low velocity, that is less than 3 meter per second, medium velocity 3 to 15 meter per second, high velocity greater than 15 meter per second. According to the type of gearing, we can classify as external gearing, internal gearing, and rack and pinion. According to position of teeth on the gear surface, we can classify as straight, inclined, and curved. Now, what is spur gear? The tooth profile is parallel to the axis of the shaft, transmits motion between the parallel shaft. That is external spur gear, internal spur gear. We can see the first diagram, we can see the teeth are cut in the internal periphery of the gear. That is internal spur gear. The second diagram represents the teeth that is cut in the circumference of the gear. That's why it is called as external spur gear. Helical means it's having some inclination. That is, the definition goes on like this. Teeth are inclined to the axis of rotation. The angle provides more gradual engagement of the teeth during meshing, transmit motion between parallel shaft. Single helical gear, double helical gear. In the picture we can see that. Then bevel gear, teeth that are formed on the conical surface, used to transfer motion from between non-parallel and intersecting shaft. So it is non-parallel one. Previous diagrams we have seen all are parallel one. This is it's not parallel one, non-parallel. Worm and worm gear consists of the helical gear and the power screw, that is worm. In the top we can see the screw type of, that is a power screw one, used to transmit motion between non-parallel and non-intersecting shaft. Rack and pinion. Rack and pinion arrangement, the horizontal railway track system will be there, like that, the same thing. The gear will be sliding over the rack. The pinion one is called as the gear. The smaller gear will be called as pinion. Then this is the nomenclature of gear. This is very important topic. Everybody aware of this topic also. So what is that means? The cross-sectional view of the gear, it is shown in this symmetrical diagram. Presents the teeth. Two gear teeth is projected over here. Face width is topmost portion is called as face width. What is addendum means? The center part of the arc is called pitch circle radius. The pitch circle radius to the topmost tooth, topmost height of the teeth is called as addendum, and the bottom line portion to the pitch circle line, that will be called as dedendum. Circular pitch is nothing but, we can it is highlighted in the diagram also, the starting of one teeth to the engage with the next teeth end, that is called as circular pitch. And the tooth thickness also it is given over there, and working depth, the gear that is penetrate up to the which level it is engaged with the mating gear, that will be called as working depth. Face, as you know, the face is the front part of the where the gear is going to get mesh with each other, that is called as face portion. Face 1. Top land is the topmost surface. So these are the various important terms that is used in the gear nomenclature. So cycloidal teeth. So we can see advantages of cycloidal teeth. Cycloidal teeth have wider flanks. Therefore, cycloidal teeth are stronger than the involute gears. Less wear in cycloidal gears as compared to involute gears. Interference does not occur at all. Exact center distance to be maintained. Pressure angle varies during the engagement. Manufacturing cost is more. This one important advantage is here, it is clearly given. Less wear. There is not at all wear that is happening in the types of cycloidal gear. Exact center distance will be maintained. So pressure angle varies during the engagement. Manufacturing cost is more. That is one of the major limitation of this. The manufacturing cost is not much low. So it having a wider flanks. Because of that only it's having less wear in cycloidal gears. Now we will see the involute portion. The previous compare with these two, cycloidal and involute. In this, the various advantage of the involute teeth that is mentioned over here. Center distance for a pair may be varied within the limits. The second thing is pressure angle is constant. What I told you the previous thing means pressure angle is a varying one in the cycloidal teeth. In this it is constant. In the previous thing we have seen the manufacturing cost is very high for the cycloidal teeth kind of. It is easy to manufacture in this. In there interference does not occur. Here it is interference occurs in this. These are coming at a various involute teeth. These are the two categories we have seen. The gear tooth forms. So in that the flanks area will be more wider area. So that's why we can tell the wear will be very less in that case. So these are the two references. In this second unit, I have explained only the basic introduction part only. In the upcoming slide, the part 2 of the unit 2, we can see the major formula wise we have see. We can see one by one, as well as basic formulas based on the problems also we will do. Based on the formulas, we will do some problems also in part 2 of gear and gear trains. So these are the two references. So which I taken the content from these references. So thank you students. Thank you for your kind attention. So we will see in the upcoming slides of this unit 2. So kindly subscribe, like the video and share share the video to your friends. So we will see in the upcoming slide video. Thank you, Ananta. Thanks.